Okay, so let's go ahead and continue a little bit on asymptotes, especially vertical asymptotes, and explain a little bit more on those. Last time I said, if we have an irrational function, and then you want to check if a point, if a zero of the denominator is an asymptote or a whole, you should substitute in the numerator, right? And if you get a zero, we said it is not an asymptote, but if you don't get a zero, that means it is an asymptote, right? This works every time. Of course, every rule there is exceptions, right? Now, there are scenarios in which, even though you got a zero, it's still an asymptote. And we'll look at those, and I'll explain some of those right now. For instance, let's take a look at, say, f of x equal sum x over x squared. Yeah? Let's take a look at this particular scenario, sum x over x squared. Now, we know, based on the fact that we have x squared in the denominator, so x cannot equal to 0. Yeah? So part of the domain, or exclusion of the domain, is x not equal to 0. So is 0 an asymptote in this case? If we follow the rules I said last time, then you say, okay, if I put a 0 in the numerator, it's going to be 0, right? So therefore, it's not an asymptote. Well, in this case, it is. Why is that? Well, we only checked 1 0, right? Notice, the multiplicity of the 0 over here is how many? 2. So we checked 1, but we didn't check the other. You say, well, if I just put another 0 in there, it's going to still give me a 0, right? So what's the point of checking the other 0, and how do I check the other 0? The way to check the other 0 is by doing the following. First, you simplify this. Yes, we simplify it. Once we simplify it, we take out all the common factors, then we're going to end up with 1 over x. Correct? And when we end up with him, okay, now better. It will be better if I record it with a video on, right? All right, so we haven't talked too much. So basically, even though it's giving me a 0 in the numerator, it's still going to be an asymptote. Why? Because we only checked first 0, right? So now to check the second 0, you have to go ahead and simplify this. When we simplify this, we took out the common factor. So we took out the first 0. Now let's check the second 0. If I put a 0 in here for x, does it give me in the numerator? Does it give me 0? Numerator now is always what? 1. Yes? So therefore, this will create an asymptote. Okay? So only the rules we talked about works if the multiplicity of the zeros in the denominator are 1. Okay? Now, as far as it's not 0 in the numerator, it works for all multiplicity. It doesn't matter. But only if the 0 in the denominator is multiplicity 1, and you substitute, and you get a 0, then that's not an asymptote. If it's a multiplicity 2, you really have to check the other one. Okay? So that's basically what it is. So in this case, yes, 0 is an asymptote. Okay? Let's take another example that will illustrate that a little bit more. Okay? Consider, for instance, we have f of x. Let's say it's equal to, say, x squared minus 2x minus 3 divided by, so here we have minus 3, that's going to be a negative 3 and 1. X plus 1, say, squared times, I just leave it x plus 1 squared. Yeah? Well, in this case, we do have this is not going to equal to -1, right? But the multiplicity of -1 is how many? 2. Yes? So when I said, well, x is not equal to -1, but is -1 an asymptote? Well, we tried the first one and it gave me a 0, correct? When I tried the one and it gave me a 0 on top, that means x, when we tried -1, that means x plus 1 is a factor, correct? So the next step is, because the multiplicity 2, more than 1, I have to check the other one. Okay. So what I need to do is factor the top, factor the bottom, and see what common factors do I have. Okay. So we know -1 is a factor. If -1 is a factor, so the top part is going to be x plus 1 times some other factor. What's the other factor? Well, to get x squared, you need to multiply by x. Yep. And to get the -3, you need to multiply the 1 by -3. It's easy to factor when you know one of them. Okay? So now when I divide that by x plus 1 times x plus 1, what happens? Those two cancels out, correct? But the remainder rational expression also have a -1 as a what? As an exclusion, correct? So now I will try the -1 in here only. So that's the only thing left. Do I get a 0 if I put a -1 there? No? Then in this case, the second -1 is an asymptote. Okay? So we have x equal -1 is a vertical asymptote. Okay? Now the only time I'm going to do this, if the multiplicity is more than 1. Yes? But if the multiplicity is 1, then that's it. We make a conclusion, it's not an asymptote. Clear? Mostly in the book, they don't have these situations, but I'm just giving you some, just in case you need to go a little bit higher calculus for that. I didn't see any in the book, so if there is any, maybe, but I haven't seen any. Okay? So now, let's go ahead and use all the techniques that we did to graph the rational, what do you call that? Rational functions, yes? Let's take an example on graphing and start from there. It says, find all the vertical asymptotes. I don't want to find the vertical asymptote. We've already done that. Let's go to the next one. It says, sketch the graph of g of x is equal to 3 over x minus 2 and state its domain. So we have a function and we need to graph this function. Okay? When you're looking at a rational function to graph it, step number 1, you want to simply look at your domain of the graph. Why? Because you want to figure out if I do have any asymptotes or not. Yes? So step 1 is the domain is, again, all real number minus the value of x that makes the denominator equal to 0. Yeah? What value of x makes the denominator 0 in this case? 2. So I'm just going to exclude 2. Yeah? Step number 2, determine your asymptotes. Find your vertical asymptote, find your horizontal asymptote. Okay? Horizontal asymptote, we said we look at the exponent of the x values on top and the exponent on the bottom, and we compare them. Yes? Now, since I only have constant on top, I don't have x, that means the exponent of x is 0. Okay? So therefore, top exponent is 0, bottom exponent is 1. Based on the rule that we studied last time, what is the horizontal asymptote in this case? Okay, let me show you one thing quick, so you don't have to memorize all of this stuff, right? We talked about the top is less than the bottom, right? Let's take a scenario, whichever scenario you want. 1 over x. That is, the top is less than the bottom, right? The exponent on top less than the exponent on the bottom. Make x as big as you can. Yes? And then divide those numbers. What do you get? A very, 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 very tiny, close to which number? No, you can go a whole lot less than that. If I take 1 and I divide it by trillions, I don't get a 1. I get close to 0. Yes? So that means the answer is what? Then the horizontal asymptote is simply 0. Yeah? So y equals 0. Now, if the exponent were the same, let's take a scenario, quick scenario, exponent is the same. I don't worry about anything else, only the first two numbers, right? Just say 2x over 3x. Yes? What happened with those x? What's left? There you go. That's your answer for the horizontal asymptotes. Yeah? Now, let's take a look at the other scenario. The top is bigger than the bottom, right? So I'm just going to put x over 1. If x is the infinity, what's infinity over 1? No asymptote. No horizontal asymptote. Yes? Does that explain a little bit better so you don't have to memorize all of these rules? Yes? Okay, cool. So now in this particular problem, we have the top is less than the bottom, automatically 0, right? So y equals 0 is your horizontal asymptote. Vertical asymptote, we said, we look at the possible vertical asymptotes. What are the possible vertical asymptotes? Are the exclusions. Yes? So the only exclusion here we have is 2. Yeah? Is 2 an asymptote? Well, 2 multiplicity 1. The numerator is never 0, correct? So therefore it is an asymptote. Yeah. So now it is time for us to start graphing. So we know on the graph, so I'm going to put my 2 lines here, right? Now what I'm going to do is, I'm going to do my asymptote. Let me see if I can see some colors. Okay, so we have y equals 0 is an asymptote, right? That's one asymptote. What's the other asymptote? X equals 2. So I'm going to go 1, 2, and make a line. Okay? Now, we need to determine how the graph is going to do, what the graph is going to do. Okay, first, does this function ever equal to 0? So it will never cross. Remember we said the horizontal asymptote can be crossed? And therefore, it will never go through this line in here either. So the graph is not going to go through this line. It's not going to go through this line, right? So we know at this line at the end is going to either be like this or like this. It is about to be determined. Which one? Yeah? Over here, we said it's going to either be like this or like that. And we're going to determine which one. Over here, similar. Like this or like that. Like this or like that. So let's go ahead and determine which one of each scenarios we have. Well, we said this line divide the graph into two portions. One on the left, one on the right. Correct? Let's see where we are. I'm going to use a point anywhere on this side. Check a point anywhere on the left of this line for x value. Substitute into the equation and see what you get. For instance, we could use 0. For x, we could use 1. I could use -5, -3, whatever number I want. Doesn't really matter. So let's use x equals 0. If x equals 0, what is the y value? Y would be 3 divided by -2, which is -3/2. Yeah? So choose easy number so you don't confuse yourself. Okay, let's see where this point is on the graph. At 0, gonna go to -3/2. Let's say this is over here, right? So the graph has to go through this point. Yeah? So that means it's coming on this side. And we said it's not gonna cross this line. There you go. This is the first portion of the graph. Now, the second portion, again, could come this way. Yeah? It could come this way. I don't know which way yet. Let's try it. Then I'm going to take a point on this side. Let's go ahead and choose, say, 3. For x equals 3, then y equal 3 divided by 3 minus 2, which is 3. Yeah? Therefore, if x is 3, so that's over here somewhere, y is also 3, so 1, 2, 3, it's over here somewhere. Yeah? So which way the graph is coming? It's coming from this side, right? Because we said it's not going to cross this line. There you go. Now, I don't need all of these. This is the graph for this particular number. Okay. Let's do another graph. It says sketch the graph 2x minus 1 over x. Two x minus 1 over x. Yeah? All right. So let's go ahead and graph that. So what is the first step? Domain. So for the domain, R, take away. What is the value of x that makes the denominator 0? 0. So the domain consists of all the numbers except for x equals 0. Yeah. Step 2, finding those asymptotes if possible. So for the horizontal asymptote, what is the horizontal asymptote? Let's take a look at that. Well, we do have a 2 on top. So if you have 2x over x, what do you get? 2. Don't worry about it. Remember, with the horizontal asymptotes, we only take the terms with the highest exponent, right? Those are the terms with the highest exponent. Is x going to make a difference here? No, so it is 2. That's your horizontal asymptote. Now let's take a look at the vertical asymptotes. For the vertical asymptotes, we only have one possible vertical asymptote, right? Which is 0. If I put 0 in the numerator, it's only multiplicity 1, right? So I don't have to worry about anything else. If I put 0 in the numerator, do I get a 0? No. So therefore, it is an asymptote, right? So y equals 0 is, x equals 0 is vertical asymptote. So now we got those vertical asymptotes, right? One more thing you could do in here is you can find what we call the intercepts. Okay. Does this graph intercept the x-axis? Let's see. X-intercept means the numerator is 0. Yes? X-intercept means the numerator is 0. So in this case, we can say 2x minus 1 equals 0, 2x equal 1, x is 1/2. Yeah? Let's go back now to the graph and see if I can graph it. Now, does it intercept the y-axis? If I want to check that, I can put 0 for x, right? But we already have 1. 0 is not in the domain, so I can't use that. Yeah. To find the y-intercept, we need to put 0 for x, right? But can I put 0 for x? Domain says you cannot. So let's do that. So let's check. First, let's go ahead and write down or put down our asymptotes. What is the first one? Y equal 2. 1, 2. That is the horizontal. Okay? Let's go ahead and put the vertical one. The vertical one is at x equals 0. So that means it is the y-axis. Okay? Now, if you ever want to know, if the graph is going to cross this line or not, you take the graph, 2x minus 1 over x, and let it equal to whatever the asymptote is. In this case, it is what? 2. Yes? Solve this equation. To solve it, we cross multiply. 2x minus 1 equals 2x. Is this ever true? Let's bring all the x's to one side. So negative 1 equals 0. Is this true? No, so therefore the graph is not gonna cross the horizontal asymptotes that we have. Yeah? So now we know for fact, if the graph coming this way, it's gonna go along like that. Yeah? If it's coming from this way, it's gonna go along like that. And similarly on this side. And similarly for these guys. All I need to do is find an interval with points and determine which way the graph coming from. And all we need is basically maybe 1 point. Because we know it's not going to cross this line. Yes? Okay, where am I here? At 0, right? So I can take a point on this side, point on that side, and see what happens in each case. On the left of 0, let's say x equals -1. When x is -1, what do I get? On top, we're going to end up with y equal -2 minus 1 over -1, which is going to give me 3. Yeah? So at -1, I'm getting 3. 1, 2, 3 right here. Yes? So how does the graph is going to look like? So it's going to come from here, it's going to go through this point, it's not going to go beyond that point. Okay? Now, let's take a look at this side. But still, this side could come down this way, or it could come up like that. Yes? But we already have a point there. X equal 1/2 is what? Is my x-intercept, correct? So if I put a 1/2 in here, if this is 1, that's 1/2. I know the graph has to go through this point, correct? So that means it's already known. What it is. Yeah? Any questions? No? All right. Let's do one more. Or maybe 2 more, who knows? Because sometimes. So let's consider the following. X over x squared minus x minus 2. Yeah. X squared minus x minus 2. So the first step is to figure out what the domain is. Yeah? So in this case, we need to figure out the values of x that makes the denominator equal to 0. So I'm going to take x squared minus x minus 2. I'm going to set it equal to 0 so I can exclude those numbers. I'm getting. Yep. All right. To solve this, we need to factor that expression on the left. How do I factor this? Looking for 2 numbers, you multiply, you get -2. But then when you add them, you get a -1. What are those 2 numbers? Switch them around. Is that what he said? I thought you said -1, +2, right? You were close. Close. Equal 0. Yes? He was giving me the answers right away. That's exactly what he was doing. So x equal to x equal -1. These are your numbers. So then we know the domain is going to be all values, take away -1 and 2. So we know the graph is not going to go through these 2 points. Now, for horizontal asymptote, what is the horizontal asymptote? So let's take a look at these. We simplify 1x, we end up with 1 over x. If x is extremely huge, yeah, so that means the statement goes to 0. So that means y equals 0 is horizontal asymptote. Again, x over x squared is 1 over x, yeah? But if x is huge, the bigger the denominator, the smaller the fraction, right? And if I go far enough, I'll probably get to 0, yeah? So vertical asymptote is, we have two possibilities, -1 and 2, and luckily for us, each one of them is just multiplicity 1, yeah? So I can check them in the numerator. Do I get a 0 when I put in -1 for x over there? No. So x equals -1, yeah? How about 2? Is it an asymptote? If you put 2 for the numerator, do you get 0? If you put 2 for x in the numerator, do I get 0 in the numerator? So that means it is an asymptote, right? So x equals 2 is an asymptote. So we have those two asymptotes. So y equals 0 is horizontal. That's y equals 0. X equals -1. X equals 2. And then let's go ahead and see what happens. Yeah? Now, is the graph going to ever cross this line? Let's see. In order for the graph to cross this line, that means there will be a time when this is equal to 0. Yes? Let's put it. X over x squared minus x minus 2 equals 0. Yes? So that means the numerator must be what? 0. So that means x equals 0. In this case, yes, it does cross that point. Where does it cross it at? This point. Yeah? Okay. Now, we can see that now the graph is divided into 3 portions because we have 2 asymptotes. Yeah? One portion on this side. Okay? One portion between and one portion on that side. So now we need to check how the graph is going to be in each portion. We know in this side, on this side, notice, the graph crosses the horizontal asymptote over here, yeah? But it doesn't over here, and it doesn't over here. So the graph is going to come this way or that way, yeah? On this side, it's going to come this way or that way, yeah? On this side, in the middle, because it's going to cross that, you have a whole lot of options. It could come right this way, go up, yeah? It could come this way, continue. It could come this way and go up. It could come from here and go down. And we'll figure those out in just a second. Okay? Let's figure out what's going on this side first. That's easy, yeah? I'm going to take a point beyond, before that one. This one was a -1. So let's say -2. Okay. So if I substitute -2 here, what do I get? Look, I'm only interested to see whether it's on top or bottom, right? So really you don't have to be accurate just to know whether it's a positive or negative. And let's go ahead and do that. So -2 over 4 plus 4 minus 2 will be -2 over 6, yeah? That's going to be a negative number. So I'm going to be below this line. So that's the first one. Okay? Of course, you can add a couple of errors to indicate it continues on. Okay, let's see what happened on that side. On this side, I need a number bigger than 2. Yeah? So let's take a 3. I'm going to put a 3. Again, I just want to know if it's a positive. It's going to be more than 0 or less than 0 in this case, right? So 3 over 9 minus 3 minus 2. Yeah? So what do I get? 3 over 4, and that's positive. So I am on this side. It's going to be this way. Yeah? So I know on this, it's going to go through this point. That's for sure. Yeah? First, I'm going to take a point in this area. Say 1. Yeah? And I'm going to put there and see what I get. So am I going to be coming from here down, or am I going to be going from here up? Yeah? Let's figure that out. So if x is 1, we have 1 over 1 minus 2, right? I said x is 1, yeah? So that's going to give me 1 over negative 2, which is negative 1 half, yes? So that means on this side, the graph is coming from here, yeah? So I got the first portion. Till there. Yeah? I don't know. Is it going to go down again? Or is it going to continue up? So I'm going to take a point here between those two. Let's say negative 1 half. And remember, we're only interested in knowing whether the answer in this case is going to be positive or negative, right? Because if I get a positive, that means I'm going to be here, it's going to continue up. Yeah? If I get a negative, that means it's going to be here, it's going to go down. So let's take negative 1 half and see what we end up with. So negative 1 half divided by 1/4 minus 1 half minus 2. Can you see that the top number is going to be negative, right? And the bottom number is going to be negative. Yeah? So negative divided by negative is positive. So I'm going to be here somewhere. Yeah? So that's the 3 portion of that graph. Any questions? I think these would be the hardest one you could ever get. All right. One more? All right, one more. This time, let's go ahead and do a little bit tricky. Let's do the following. It says x squared minus 9 divided by x squared minus 2x minus 3. Yeah? So we start with domain. So what's the domain? Well, let's figure out what the zeros are first. X squared minus 2x minus 3 equals 0. That's the denominator. Yeah? And then we need to factor this. So to factor this, we're going to find two numbers. You multiply, you get a negative 3. When you add them, you get a negative 2. And those two numbers are x minus 3 and x plus 1. Okay? So we have x minus 3 equals 0, x equals 3. And then we also have x plus 1 equals 0, x equals negative 1. So my domain is R, take away negative 1 and 3. Notice again, both of these are multiplicity 1. When they are multiplicity 1, that's good. So I don't have to do a whole lot of work to solve them out. Okay, multiplicity 1. So is negative 1 an asymptote? Let's go up here with a negative 1, right? So negative 1 squared is 1. 1 minus 9 is negative 8. It is not a 0. So x equals negative 1 is a vertical asymptote. Yeah? Let's try 3. 3 squared is 9. 9 minus 9 is 0. So therefore, it is not a vertical asymptote. So x equals 3, we say it is simply a hole, right? It is that circle we're going to do. Now, what is the horizontal asymptote? In this case, what do I have? X squared on top, x squared on the bottom, right? If I divide them, what do I get? 1. That's it. So y equal 1 is horizontal asymptote. Remember, the coefficient here and here, they're both 1, right? That's why we got the 1, right? Okay, now, does this graph crosses the y equal 1 line? Let's see. Okay? What did we say we do? Just take this, set it equal to 1. Yes? So we have x squared minus 9 over x squared minus 2x minus 3 equal 1. Yeah? Let's cross multiply. So x squared minus 9 equal x squared minus 2x minus 3. Done? So what happened with those x squared on both sides? They cancel, right? So now what do I have? Minus 2x minus 3 equal negative 9. Okay? Then we end up with the following. Is that what we got? Yeah. So let's isolate the 2x. So minus 2x equal minus 6, correct? Then x equal minus 6 over minus 2, x equal 3, yes? However, what do I know about 3? It's not in the domain. It's not in the domain, that means it doesn't cross. Yeah? So that's not acceptable. So that means it doesn't cross it. Now, if you don't want to get into this situation, here's how you do it better. Let's erase this. Now, notice, did we say x plus 3, x equals 3 is a 0 on top? Yeah? So that means it's a factor, correct? This is what I'm going to do. X plus 3, x minus 3 over, we already factored that one, yes? Which is, I need to fix that thing. Okay, so it's over x minus 3, x plus 1, Correct? Now these two cancel. What's left? X plus 3 over X plus 1 equal 1. Then X plus 3 equal X plus 1. Is this ever true? These two cancel out. What's left? 3 equal 1. Yeah? It doesn't cross the horizontal axis, asymptote. We clear? So two ways. If you don't simplify it, you have to watch out for your answer if it's valid. How do I watch out? I check it with the domain. Yes? If you simplify it, then you shouldn't have problem if you found any. So let's go back and graph now. Let me give myself a little space. Let's start with the asymptotes again. That was y equal 1. So that's y equal 1. Let's make it over here. This is 1, yeah. And, well, I should have left that thing in there. Anyway, y equal 1. We have x equal -1. That's -1. We have x equal 3. Well, at 3, it's not an asymptote, right? It is simply what? Oh, but how do I know how far it goes up? How do I know where do I put the circle? Do I put the circle here, 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 here? I don't know yet. Let's figure that out. Okay? Now, to figure that out, I should have left those numbers down, but I'm going to go ahead and do it again. So this we said it's x minus 3, x plus 3. Correct? Yeah? This we said it is x minus 3, x plus 1. And we also said, what happened to those? They cancel out. Yes? Now, let's put the 3 over here in the leftover. What do I get? 3 plus 3 is 6 divided by 3 plus 1 is 4. So that's 3 over 2. Yes? So now I'm going to go up from this point to the point 3 over 2, which is simply there. Yes? And I'm going to put my circle right there. You see how we found it? So after we take all the common factors out, we substitute it and see what we get. Okay, now, well, with this, we already know, I know the graph is not going to hit that one, it's going to be on its side, right? Okay? Is that understood? Yes? Notice, we said the hole is where? Right there. Yeah? But the graph is not gonna create anything, it's gonna create a hole over here, right? So it has to be here. So that's why we came here, from down to this point. Because we know it's above the asymptotes, right? This is your asymptote. This is your asymptote. Graph is gonna come from here or like that. Remember? If it's gonna go through this point without touching it, then it has to be on this side. Now on this side, to figure it out, is it gonna come from here or is it gonna come from here? We take a point. This is a -1. Yeah? Let's do -2. If x equals -2, Let's go back to the original now. 4 minus 9 is negative 5. Yeah? What do I get on the bottom? We have 4 plus 4 is 8. 8 minus 3 is 5, equal negative 1. Now notice, at here I'm getting down here. And that's the graph. It's just missing that little point for the whole we got. Yes, that x-intercept will be right here. And actually, if you take that top number, you set it equal to 0, you end up with 2 intercepts. Let me show you what they are. So x squared minus 9 equals 0. X squared equals 9. Yes? So x equal plus or minus square root of 9, which is 3, right? But what did we say about 3? It's not in the domain, right? So the only intercept would be minus 3. So this point over here would be your minus 3. Yeah? Does it have a y-intercept? It does, right there. You want to figure that out? Put a 0 for x. If I put a 0 for x, this one, that one, all gone. Minus 9 divided minus 3 is 3. So this point over here would be simply 3. Yep. Okay. Any questions? All right. We still have one asymptote to go. And this asymptote is called slant asymptote. If now the last condition on those n and m we said the rational expression last time we said it is a n x to the power n plus we said whatever, correct? And we said over here we have a bm plus times x power m plus we said whatever, right? Because we're only interested in those two terms, right? And we put in 3 conditions for n and m. We said if n is less than m, then y equals 0 is your horizontal asymptote. Yes? We also said n equal m, then y equal an over bm, that is your horizontal asymptote. Yeah? We also said if n is greater than 0, greater than m, we said no, notice that, we said no horizontal asymptote. We said no horizontal asymptote. But is there any other asymptote? Yes? We have what we call slant asymptote. We have a slant asymptote. What is a slant asymptote? It's an inclined line. Yes. So another way, we can call this a slant asymptote, which means the graph may go something like that, along this line. Yeah? Okay. How do I determine if I have one? Yeah. Last condition. If n equals m plus 1, if n equals m plus 1, another way, if n is 1 more than m, such as x over 5, x to the 5 divided by x to the 4. This is 1 more, right? Or we can say x squared over x. This is also 1 more. Anytime you have that condition, then you do have a slant asymptote. Okay. How do I determine? Then we have, there is then we have a slant asymptote that we have to worry about. Yes? How do I determine what that slant asymptote? Let's do an example and figure that out. And we're going to go back to basically division. We're going to use the long division to determine what the slant asymptote is. Okay? Let's go ahead and do that. Suppose, for instance, it says find the slant asymptote. We have f of x equal x squared minus x divided by x plus 1. Technically, in this case, we don't have horizontal asymptote, right? But notice we have x squared here, we have x here. So the top is one more than the bottom. So that means we have slant asymptote. How do I determine what that slant asymptote is? I'm just going to go ahead and divide this. Okay? I'm going to go ahead and divide this. And your answer is your slant asymptote without the remainder. Your answer without the remainder is your slant asymptote. Let's do that. So we have x squared minus x. We're going to divide that by x plus 1. Okay? X squared divided by x is x. X times x is x squared. X times 1 is x. And then we said we changed the signs, right? So I'm going to change the sign here and change the sign here. What do I have left? These cancel out. Minus x will be minus 2x. Yeah? I can still divide. Minus 2x divided by x is minus 2. And minus 2 times x is minus 2x. Minus 2 times 1 is a minus 2. Change the sign. So we end up with 2. So I can no longer divide. Yes? And this is my slant asymptote. Okay? We're clear on that? So you have to go and do long division. Because not all the time it's going to be x plus 1 here. You might have x cubed over x squared, right? So in this case, you have to go ahead and do exactly long division. If you wanted to do synthetic division on this one, because it's a linear factor, you could have by choosing -1. Yes, let's see if we figure it out. And then we have 1, -1, and 0. Yeah? So I'm going to take the 1 down. Okay? 1 times -1 is -1. That's a -2. And that's going to give me -2. I'm sorry, +2. That's a 2. And these are your, in this case, this is your asymptote. Yeah? But you can only do that if you're dividing by a linear factor. Okay? You can only do that if you're dividing by a linear factor. And that would be x minus 2. Yeah? Okay, so now we figure out what's the so we're going to say slant asymptote y equal y equal x plus 2. Did I get x plus 2 or x minus 2? Minus 2. So we're just going to put minus 2, yeah? Let's continue with this and try to graph it. Okay, now, we got x minus 2 for slant asymptote, yeah? What else do you have? We need to figure out the domain. Let's figure out the domain. The domain is what was it? R, take away -1, yeah? Do I have a vertical asymptote? Let's see. I only have a multiplicity 1, yeah? So I can check it in the numerator. If I substitute -1 here, what do I get? 2, yeah? It's not 0. So therefore, x equals -1 is vertical asymptote. Okay? So now, we have two asymptotes. One of them is x equals -1. The other one is y equals x minus 2, correct? So I'm going to go to the -2, and I want to graph this line. The slope is 1 to 1, right? I'm going to go up 1, right 1. And this is my slant asymptote, like that. So now, how does the graph is going to look like? Well, here's what it is. Either going to come this way, like that, and like that, or like that. So let's see which one, how it is. So we have two portions. We need to find at least two portions. Let's take a point in this area. Let's say for x equals 0. For x equals 0, what do I get? Should I end up here? Should I end up here? Or should I end up in this side? Or should I end up somewhere in this side? Okay? If x equals 0, then y equals 0. Yes? Actually, also if x equals 1, y equals 0 as well. Yeah? So we have 2 points of let's say if x equals 0, y equals 0. Let's say x squared minus no, that's not one. Okay. But then again, was that +1 or -1? Oh, +1. That's fine. Again, for x equal 1, y equal also what? 0. So we know the graph is going to go through this point and this point over here. Yes? So that means it's coming what? Going to come down and it's going to go in that area. Okay? So now we can take a point on this side. Point on this side, let's see what we get. -2. So it's going to be 4 minus 2 is -2, that's 4 plus 2. That's 6 over -1, -6. So basically, it's going to be in this region. And that would give me in that region. Okay? Let's do another one that will probably give us in this region. Okay. Consider, for instance, x squared minus x minus 2. So we have x squared minus x minus 2 That's divided by x minus 1. Okay? All right. Let's divide. Let's figure out what the slant asymptote is. So for slant asymptote, I'm going to divide these. X squared minus x minus 2. You want long division or syntax? I'll do this long division. You guys do synthetic division if you want. Okay? It's easier with the synthetic division. X minus 1. But I'm going to do long division just to refresh your memory on long division. So we have x squared divided by x is x. So that's going to be x squared minus x. Yeah? And then we're going to go ahead and change the sign. Was it good? And then what happened? These cancel out, we're left with minus 2. Okay? So that means what? This is my slant asymptote. Okay? So then we say, let's go ahead and do that. Erase this. Then y equal x slant asymptote. So far so good? All right. So let's go ahead and continue with that. So now, what is your domain? R, take away which number? 1. Is x equal 1 a vertical asymptote? Let's see. 1 minus 1 is 0. 0 minus 2 is minus 2. And it's only one, well, it doesn't matter what the multiplicity now we're looking at. So x equal 1 is vertical asymptote. Yes? So now let's go back to our graph. Asymptote number 1. Vertical asymptote x equal 1. This one. Yeah? Slant asymptote y equal x. So that's a 45-degree line, right? So the graph, again, on this one is going to be like this, like this, like this, or like that, correct? So we need to know which portion of that is going to be. So let's worry about this line over here, because that's the line that divides the graph into 2 portions, correct? Let's see a number before, yeah, and a number after, and see where we land. If I land in this region, goes like that. If I land in this region, goes like that. If I land here, it goes like that. If we land here, it goes like that. Let's see. For x equals, say, 2, yeah? X equals 2. When x equals 2, we have 4 minus 2 minus 2 divided by x 2 minus 1. And that should give me a 0. Yeah? So this is where I landed. So how does the graph look like? It's going to come from here. Yes? Let's see on this side. On this side, this is your 0, right? Let's take a negative 1. So -1 is going to be 1 plus 1 minus 2 over -2. And that's also going to give me 0. Isn't that true? So I am here. Yeah? So how does the graph look like? And this is how this graph looked like. The first one we did, we ended up in the middle in both of them. So that gives me here or here. And this one we did, we ended out on both outside. That gives me there and there. Any questions? No, I think that should cover everything that you should have guys have for the test next week. Make sure you take the test before Friday. Okay. I was hoping to start something over here, but this is everything on chapter 2 we're gonna cover. Next time we meet, we're gonna go into chapter 3. Yeah. And that's it for today. You guys have a good day.